Hey everyone, GM. How's everyone doing? We'll let everyone get a second to get settled in, and then I'll kick things off. Let a couple people trickle in. Cool. All right. Hey everyone. Super excited to kick this off with you guys today. Today we'll have a ZK email workshop. Let me quickly introduce our speakers and panelists. We got Ayush from ZK email, who co-founded this. And we've got Root, who's on DevRel for ZK email at PSE to help folks like us implement this tech into our projects. And then we've got the Mach 34 folks, Jack and Ian. These guys have been building ZK email into Noir and have a bunch of practical advice on how to actually make it work for us. Quick app update on NoirHack. We got the week 2 action items on the Notion page right now. And this week we've got a ton of cool workshops. We got this workshop with the ZKML folks, and we've got workshops like the one with Michael from our Noir team. We'll talk about unconstrained functions for all you advanced folks out there. But today is all about ZK email. We'll learn how to do some cool privacy preserving stuff with emails, which will hopefully open up a ton of cool possibilities for what you guys are building. So I will hand it off to Root to go into the workshop.
Yeah, so let's go dive into ZK email. Let me just share my screen. I also dropped some useful links already in the chat. Okay. Okay, so as Rafi said, I'm Ruth. I'm a DevRel engineer at ZK email, and we are here to show you how ZK email works and how ZK email Noir works and how can you integrate it into your NoirHack project. So the plan for today is going through some basics of what ZK email is. Then we will talk a bit more about how to integrate it into your app using the registry and SDK. We will cover a bit briefly some dev tooling, and then we will go deep dive into ZK email Noir with Jack and Ian. So what exactly is ZK email? So turns out that some time ago, due to anti-spam and anti-spoofing reasons, emails started to be signed according to DKIM protocol, which means that every time someone sends an email, there is a RSA signature from the sender domain with a SHA-256 of some of the contents of that email. And what ZK email does under the hood is that it wraps this full signature into a ZK proof, which allows you to parse and do selective disclosure. So you can verify all of those emails and still maintain some parts private. And this is pretty cool because you can move a lot of Web2 data into Web3. You can verify a lot of interesting data you might have on your inbox, but still maintaining some control of your own data and also some privacy around it. And you can programmatically extract arbitrary information using ZK regex, and you can move this data around to any service or any chain, making it portable. So one of the most intuitive use cases I see for ZK email is like this whistleblowing example where you might have some really important email with really important and impactful information, and you want to reveal this information to the world, but you still want to maintain your identity private due to security reasons. And You can do this with zkemail by simply parsing the whole email content and hide and still being able to hide all of the parts that might reveal your identity. Like, for example, the two fields on that email. And we have a lot of infrastructure for people to build apps with zk email. But the easiest way to start to play around it and build some cool stuff like in a really simple and fast way is by using our registry and our SDK, which I'm gonna present right now. Let's like the registry, you can see it like a place where you can create a blueprint, and the blueprint is something that defines what is the information that you want to parse and to reveal or hide from some email example you might have. After defining this blueprint, we deploy all of the infra for you without you having the need to understand what exactly which ZK framework is being used, how should you build the circuits and etc. And also this is pretty cool because you can also share any blueprint that you created with others, and you can also reuse blueprints that other people just created. Then we also have our SDK, which you can integrate any blueprint that you created previously into your code base with just a few lines of code. So as you can see from this example, you can just initialize the SDK. You can get one blueprint from the registry by just simply get the slug or even the ID from the blueprint. Then you can generate a proof, and you can specify if you want it to be locally or remote for privacy reasons. And you can also just verify with just a simple line of code. So yeah, as you can see, it's pretty straightforward. You will also have our docs in this QR code if you want to check it out. And we also provide some boilerplates and templates for how to start with a really simple example to use the SDK. And now we also want you to get inspired for some stuff that you might want to build. So I will just show you some interesting examples that people are building with ZK email. So you have like this example of a decentralized domain marketplace where you can prove that you own a Namecheap transfer email, and you can build a marketplace on top of it. And also, as you all might be familiar with Stealth Note built by Salil, it's a web app where you can prove that you belong to an organization and post about it, but still remain your identity private. Yeah, as a side note, I also wanted to just briefly cover our archive because this solves a really important problem that we started to have when trying to verify old emails. And the issue is that the public keys for each sender domain are public, and you can simply query them. But the issue is that once they are expired, which is happening more or less like 6 months to 1 year, they are deleted and they are completely gone. So then you lose the ability to verify these old emails. So what we did is we have this DKIM key archive where we store each public key for each sender domain that we might know. And yeah, and we also reverse engineered some of the public keys of some older emails by just having like two examples of selector and domains, and then we can reverse engineer their public key. So also there is a way to contribute to this archive by just uploading some domains and some selectors that you might have on your inbox. So you can check it out on our website and do it if you want. Yeah, so right now I also wanted to cover a bit like what is the process of creating a blueprint on the registry. And right now we still are working to deploy the Noir version into our registry, but should be completed until the end of the week. And it should be reassembled something like this on this screenshot. But yeah, for now, let's just try to do a really cool. So I go to registry.zk.email. As you can see, you can check a lot of blueprints here. So I will create a blueprint for proving that I got into NoirHack. So for this, you can do like download this message, and you just download a EML file that you can upload it here afterwards. So like I have it here, and I also can show you. It looks like this. So let's do proof of NoirHack. So I'll just upload that in EML file. And also for your information that can be relevant in the future, if you want to prove something that we don't have in our archive, this email was sent by this domain, Aztec Labs, which we didn't have in our archive. So what I did is that I just queried this domain to look for their public key. You get the public key, so you check that it exists indeed, and then you just call our API to add this domain in selector to the archive. Okay, so then you have like this sender domain, which should match this domain here on the DKIM signature of the EML. And for now, I will skip the body hash check because I just want to verify some stuff on the headers. So I will just create a really simple pattern with the subject. I will just increase the max length here. And yeah, so we have this default one, default regex, which will show all of the subjects as a public output. But yeah, for now, I can also just do, I want to just show this part. So I can put this here. and then put this as private. And yeah, so you just show welcome to NoirHack from the old email that you have. So then I will just submit it, and it's compiling, and then later on you can prove that you have an email for NoirHack. Okay, so that's it on my side. I will pass it over to Jack.
Do you want to actually? I can pull it up on my screen. How do I pop this? No, sorry. Give me a second here. Just make it bigger. Okay. So now we'll go through actually zkemail.nr on the lower level. So right here is QR to the GitHub. It's also linked in there in the chat if you want that. So let's start with that. And I'm going to go through the repository, but you don't actually need to clone the repository as you're working with the circuits at the lower level. You can just like import nargo.toml for input generation. You can use the npm package. Ton of really good examples in here. Again, I'm working with it because I can show everything off. You don't need to clone anything to use zkemail.r. You can just pull stuff in. So let's start out with the most basic example. We're going to take basically, as Root said, an email by verifying an RSA signature over a header. And then if you want the body as well, there's a body hash included in that signed header. So if you validate that signed body hash, then you've got authenticity over the entire email. Okay, so really quickly, the inputs, like some of these might make sense, right? Like header, body, pub key, signature, you can figure out how those work. And then you've got auxiliary inputs, body hash index, DKIM header sequence. You'll see other stuff in here as well that might seem more confusing, but the procurement of all these inputs, you really don't need to worry much about. You need to wire them up, right? But like how you actually get these bytes or these indices, you really don't need to worry about. So don't fret too much about that. But okay, so let's start out with the most basic part, the first part, maybe not the most basic part, but which is actually verifying the header itself. And in Circon, this is a lot of work. There's definitely abstraction of templates and stuff, but it's not pretty. Noir, it's one line, right? You have to instantiate the public key struct correctly as you pass it in and stuff like that. But all you have to do is call pubkey.verify DKIM signature. You pass it in the header, pass it in the signature. And I mean, if you go in, again, there's abstraction, there's all this stuff going on. There's further layers and layers as you get down. But for your purposes, this will hash the header. It'll check the signature by the pub key over that header, and it'll only continue if it passes, right? So that's the first step. Cool. We also might want to operate over the body, right? Maybe there's some interesting information in there. Maybe there's not. Maybe you're doing a use case where you don't need this, and you don't need to be verifying the body. But in this case, let's say we are. You're first going to have to get the body hash out of the header. And this version does not use regex. This is, we actually have a version with like regex v1 that has regex for all the string searches, but we're actually in regex v2 now for Noir and across zkemail. And that's not quite production grade. So we're still going to use this and it should be pretty secure according to the audit. So and again, body hash index, DKIM header sequence, you just toss them in there and you're good to go. And this will pop out the body hash, and the body hash is base 64 encoded, so it'll also decode that into the SHA-256 bytes that you're expecting. And because we verified the signature over the header here, this is the signed body hash. This is the authentic body hash that the mail transfer agent asserts is correct, right? Meanwhile, we have our body that we want to operate on. This is the actual plain text that we might want to do like selective reveal over, or just like check some information, right? We need to constrain that to be correct. So we basically just SHA-256 hash the entire thing. This is pretty expensive, right? Like something like 100 bytes or 100 constraints per byte, 100 gates per byte. We'll get into some tricks for that in a second, but you gotta hash the body in order to operate on the body. And then once you've done that, you just check that the signed body hash matches what you computed. And there you go. You've validated the authenticity of the entire email. Except what does that really mean? Signed by who? Without actually having like the public key infrastructure, it's kind of meaningless, right? So one of the things we need to do is export out the public key. And the cheapest way to do this is to hash it into a single field element, especially if you're going on chain, right? You want to minimize the work that the verifier is going to have to do. So we'll hash this into a single field element. And then, if you're on just like a backend web service or something, maybe it looks it up against like Cloudflare or Google's DNS. Maybe there's an on-chain registry of all the authenticated public keys, which if you're interested in that kind of supply chain, I'd probably investigate more in the Telegram, exactly how to do that best. But in general, maybe you'll probably have Kim registry on chain. By the way, one nice thing about like Aztec specifically, not just Noir, is like you can check this privately. Like you could instantiate this as a public immutable in Aztec, which is actually privately accessible, and you could validate the DKIM key, the public key, without revealing which domain. You could do this in a contract too. You'd have to add like a Merkle root, a Merkle proof, and the infrastructure to kind of manage that, but pretty simple to do in Aztec. And then also, like let's say we're doing ZK P2P. I send Rafi some money, right? And I don't want to be able to, well, maybe I want to, but the app doesn't want to allow me to keep using this email over and over and keep withdrawing money out. So I need a way to nullify this email. And this is the simplest way to do it. You just hash the signature. There are issues with this. The first being, you might be able to predict the pre-image of the signature, which like if it's not particularly like the body and the header are fairly uniform, you might be able to actually reverse engineer the pre-image. So you could leak that. There's I think it's OPRF. I don't think that exists in Noir yet. I'm sure someone will get it with CoNoir pretty soon, but there are ways to get around that, just not trivially today. And then also like some services, you might be able to like resend an email. Like you could go on the website and say, send me another copy of this email, and that's going to give you a different signature as well. So you need to be resistant against that as well. But for the most basic level of kind of double spend resistance on emails, this is a good way to do it. So that's the most basic example. And we'll go through some of the other things, most of the other functionality that comes with zkemail.nr. The first would be, this is a 2048-bit signature. Vast majority of signatures you will see are 2048-bit. The only one I've ever seen that's 1024. I'm sure there's others out there, but the only one I've seen is and worked with is GitHub.
Jack,
Which is
sorry, one quick question in the Q&A.
yeah. So this is the circuit we write on top of. Yes. So, okay. Exactly. So you can see this is the library and it's got all this stuff here. And then this is an example circuit. So we import ZK email, a couple other things. You don't even need to import that. And that actually is a new package, which that needs to be updated. But so yeah, we import all these things and then string them together. We also don't need that actually. So it's pretty simple. I mean, for the most part, a lot of cases you can pretty much copy paste a lot of the example stuff and get 99% of the way there. Obviously, string searching, regex, stuff like that is going to be slightly more manual. We'll get into regex actually in a little bit, but yeah, you're importing a library and then writing a circuit. Hopefully that answers the question. Okay, yeah, so GitHub's 1024-bit, and that's implemented as well. If for some reason you had like 4096-bit or something else, just copy paste the implementation into like ChatGPT or run cursor over it or something. Tell it you want whatever key length. And it should be able to do it instantly, or even do it manually yourself. It should take like 2 minutes. But you would have to implement it for other key lengths. The input generation should be able to handle it though. It's just like arithmetic circuits, constant size stuff. So you would have to do that. Partial hashing. Okay, so I mentioned that hashing the body is super expensive. A really neat trick is that you can actually partially hash the body outside the circuit. And this works when you have like maybe the last 200 bytes of the body of your email is like super interesting and has all this information you want. The first 800 is just filler, it doesn't matter. Outside of the circuit, you can partially construct the hash using like the first 800 something bytes. And then inside of the circuit, you'll give it that partial hash state. You'll give it the rest of the bytes to finish the hash. And then the circuit will complete the rest of the hash process. And this is like free optimization. It's very easy to use. If your use case supports it, there's literally no reason not to do it. It's going to save you a ton of constraints. So again, it might look a little confusing with you've got like now a different body length, you've got these extra parameters. Don't worry about it. You really just need to pass in, like you need to wire them up inside of the circuit, but obtaining those inputs is really not a concern. The one caveat on that is that it works when the bytes are at the end. It doesn't work when the bytes are at the beginning. So what you can do, this is a lot more involved, but maybe like a lot of emails you'll see have like the really interesting information at the beginning, and then you'll see all this CSS and stuff at the end that you just don't care about. Maybe you've got like a use case like I want to prove I took a flight somewhere. And I don't care that I'm revealing I used like American Airlines, but I don't want to reveal the last four of my credit card number. I don't want to reveal my name, the date I flew on, stuff like that. Maybe that's in the first like 10, 20% of the email. I could use partial SHA-256 var start, beautiful naming, hash it and export that partial hash out of the proof. Now it's not constrained yet, but you could potentially you could either string together a bunch of proofs that you prove locally if you really needed client-side privacy, and then recurse over them. You could send it off to a server, and again, maybe you don't care about them knowing that you took American Airlines. Maybe you're going to recurse this in Noir, or maybe you're even going to compose with like some ZKVM. You're going to use client-side privacy for the important stuff. You're going to use Noir, then you're going to use a ZKVM that'll be easier to deal with the hashing, or even like Circom with Icicle or something with the hashing on the back end, and stick the two proofs together, kind of. maybe not even recursing, maybe you just like verify two proofs, right? A lot more involved for sure. Definitely doable though. So if you have like really big emails, you're probably gonna have to do something like that. If you have like some critical privacy element, you can select out the exact bytes that you need, hash that part, and then put the kind of stuff that's not confidential on a server. Compose those together. Extracting addresses. Okay, so again, you're probably gonna want to use regex in the future. But if you have like a simple use case where it's just like a single recipient or like sender or something like that, it does ship with a pretty easy to use API where you can just get email address. You have to instantiate like to or from. But header, again, to and from, or to header sequence, to address sequence. Those will all be supplied for you by input generation. And then that'll pop out the email address. So for a lot of use cases, this is sufficient. There's definitely some complex ones where this isn't good enough, but I would expect the majority of things that you're thinking of would probably be served by this. And then the last one I'll talk about really quickly is removing soft line breaks. Not going to get into all of it, but essentially like emails are sent in like 7-bit encoding, which is not UTF-8. And one artifact of that is like when email services need to deal with that, they'll use something called quoted printable encoding, and that gives you basically these soft line breaks at every 80 bytes in your email body. And it's super annoying to deal with, especially if you're trying to string search or regex match. So what you can do is you can just constrain the removal of the soft line breaks. I'll give you body, decoded body. So instead of operating on body, you're still going to verify the body. You're going to hash over the body. But then once you verified the body, you can decode the body and then operate on top of that to make string searching or regexing a lot more straightforward. Cool. So how do we use this? I'm just gonna do witness generation just for the sake of time. Couple of other notes. I'm using this zk-ML prover class, but this really just wraps like Noir and Ultra Honk backend or whatever you're using. I guess no one's gonna be using Plonk pretty soon. In fact, in the regex, I don't even touch this, so don't think too much about that in the demo. But yeah, so that first example I showed you, that's it. Basically, you're gonna give it the email. Where's email? Give it your email. There's examples. I think I sent a link with one that's hooked up to a Vite front end. But in this case, we're just importing it from the file system. And then we're telling it the max header length is 512 bytes, max body length 1024, because again, it's a circuit. It needs to have these max lengths. And sorry, what am I looking for? That's it, right? You'll call generate email verifier inputs from zkml.nr. The JS package, it'll give you your inputs, simulate it, good to go. Maybe like you might have other inputs that you're using in your circuit. You might add those in, or you might rename these inputs, but that's pretty much it. Partial hashing also looked kind of confusing, right? Not really. All you do, SHA precompute selector tells it like, this is the text I want to partial hash up to, and it'll find that spot, partial hash up to it. It'll give you the partial state. And then as well, in this case, because we're hashing a lot less, we're just setting a very small body length, right? Good to go. I'm not going to deal with masked header. Okay, so extracting the sender and recipient. This all is input validation or output validation. So don't worry too much about that. We want the from address, extract from. Want the to address, extract to. There we go. And I'll show a little more about bounded vec parsing in the regex, but it's very simple. This is just actually validating the exact stuff. So again, email address is also very simple to get. Removing soft line breaks, you just set it to true again. So the point of all this is, there's a little bit to wire up in the examples. The input generation is very, very straightforward as well. You really don't need to worry too much about how to get anything. Then, yeah, if we just want to don't worry about that. Okay, yeah, my computer is not very quick. So, yeah, unlike M1s or especially M3s, this is pretty lightning fast with proving. So this is pretty abysmal. Again, I need a new computer. Cool. So that's ZK email. Again, I would just start by kind of taking any of these templates and wiring it up from there. If you have questions integrating it, definitely hop in the Telegram. I can go on a ZK regex in a second if there aren't any questions, which I don't see. I'm just gonna go for it. Okay, so ZK regex is in a little bit less of a production state. If you really need regex matching and you're feeling a little intrepid, you can try to do it right now. I'd expect in the next few days to see something a lot more put together. But yeah, uh, this is going to take a little bit more to get working. It still works though. Just keep in mind, it's going to be a little more manual until like packages are released and things are finalized. There's a version 1, which was pretty much production grade, but ZKML has iterated and made a new version of the compiler that can support more regexes. So this is kind of built from scratch and also mirrors that the CIRCOM implementation. So yeah, you might have to bear with a little pain if you want to use it. So I'm going to use the CLI a little bit, but you probably, I haven't tested this, but you could probably just get it working in JS. Eventually, you won't need to do any of the CLI stuff. You can just generate everything from JS. Only thing you need to set up is the template. So also keep that in mind. But let's jump into actually regexing. Okay, so the first thing we want to do, I'm gonna do the timestamp regex, which is this expression right here. Okay. In order to actually generate it with the CLI, we need to create a template that defines it, like decomposes it. This is very simple as well. Like if you're struggling again, just give it the context of like one of these examples, throw it in the AI and it should figure it out very quickly. So basically we're splitting it up into parts, pattern. The thing to note here is this public pattern. This doesn't mean it's actually public. This is just defining that we want to capture this substring. In this case, we want like the timestamp, the exact value there. And also in this case, we know that the timestamp is always going to be 10, right? And maybe we're working with an email, and that email could be like 80 characters. It could be up to 320 characters. So if this was an email, we would probably set 320 here, and that defines like the max length of the substring to extract. And this is more or less kind of an efficiency feature that allows us to minimize the amount of work that we have to do when capturing. Otherwise, we would have to operate over the entire haystack, the entire like body or header. So fairly simple though. Again, you just specify what parts you want to actually extract out, and then this is your entire match, right? So once we have that, we have everything we need to generate the regex circuit as well as the inputs that we're going to give to it. So again, I'm going to use the scripts, the CLI. And this is set up to generate for all of the templates. So there's a little extra stuff in here, but this is really what we care about. We're running the CLI binary, which is here. We're going to tell it we want to run it decomposed, which is that template where we had like pattern, public pattern. That's the decomposition. Actually pass it the path to that. Tell it where we want it to output, give it a name. You don't even really need the name for Noir. And then tell it you want Noir because it'll default to Circom. And if you run all that, that's all you need to get two artifacts. The first is this timestamp graph, which you don't really need to worry about, but you need for input generation. So just keep in mind that it exists, as well as the actual regex itself, which is this. So this is all auto-generated. We don't really need to go into exactly how it works, but essentially you've got all these inputs, which the input generation will handle creation for you, as well as, in this case, we've got one capture group. So it's going to return the single one. If you have 10 capture groups, it's going to return 10, each with those max lengths as you set them. Really don't need to worry about any of this. If you were like just developing locally, you really didn't want to deal with JS. There's also this has some hard-coded inputs, but and a bunch of other stuff to kind of manually handle it. So you'd have to pick through it. But you could generate like a prover.toml or even like the formatted inputs when you run this and you supply it the right inputs, and that'll give you something like this, and then you can turn around and dump those into a test and run it this way if you really wanted to. But we're gonna show an end-to-end example with CK email that we hooked up into JS. So first off, let's look at the circuit. So if you all remember just pure ZK email, the first example, it's going to look very similar in a lot of ways. So again, like that one question asked, like we're importing the ZK email library. These are all the inputs we expect, so you can kind of see how we're composing like a new one now. We import that library. We have to wire in all the inputs again and do the same thing here. Again, this is pretty much copy pasted from the 2048-bit verification, right? And then we've got all these inputs, kind of confusing, right? Not really. All we have to do is we import our regex. We have the number of capture groups, we have the length of, in this case, it's one capture group. Maybe we've got many, but those consts, as well as just regex match, right? And then all we do is regex match and wire all those inputs in. One thing to note is like the regex match has this in haystack, and the input generation will give you a haystack. What we want to do with ZK email is we want to regex over like content that we've already authenticated. So in this case, it's the header. Maybe in your case, you're regexing over the body, but we want to specifically make sure that whatever the haystack is, we're actually using something that's been validated. It's signed header or signed body. So we want to make sure we pass that in. But we just call regex match, toss in all those inputs, and it's going to pop out a substring for you or multiple substrings. And maybe like, okay, so maybe we're doing something where you're getting like a ticket to some conference by proving that you received a DevCon 2024 acceptance email. Maybe you're like, in this case, you wanted to prove that you received it at some date. Maybe you could like hard code some timestamp in this circuit and then do a range proof. You'd have to convert this to a number from bytes, which is pretty trivial to do. But you just do a range proof on that, and you don't actually have to export it, even though it says public pattern. Again, the point there is it just captures the substring for you, and then you can do whatever you want inside of the circuit. In this case, we are gonna actually export it. But so yeah, that's the process of like composing regex together right now. And then what am I looking for? Okay, so we've got our timestamp graph. I mentioned we've got the email. Again, this is not totally production grade, so we had to go here and WASM pack it. If you wanted to build it for the web, you'd have to target web, but we did that already. Import CK email, import Noir. We don't even actually use BB because this is just simulating the circuit, but if you were to prove, it's one extra function call. And then we import the input generation proving system stuff from that WASM packed CodeGen utility that we have, right? We can see when we go to generate like an email, the email inputs, it's the same thing, right? Generate email inputs. And then we've got a little extra work here to actually get the regex. Again, this is not polished. There's actually some bugs here, which are easy to work around, but things that you wouldn't see hopefully in a couple of days. First thing we want to do is our haystack for the regex is the header. So we're just going to grab the header back out. We're going to pass it into the circuit inputs generation function. Also going to give it the regex graph, like the DFA, I think. And we're going to tell it we're generating it for Noir. Those are like the main parts of this. As well, this is like the max length. I don't know why this is off by 4. It is. It should be 512 because we're working with 512. And then our maximum match length, this is a little bit manual. You would say, like, in this case, I expect the maximum number of bytes I have to go through to get to the end of the regex is like 100 bytes or 200 bytes or however many bytes. But you would set this the same way that you set it here, max match length. And that'll just make sure everything's padded to the right length and make sure the inputs generate correctly. So all you have to do to get all these inputs is run that. Same as kind of generate email verifier inputs. Cool. Now we've got our inputs. It's gonna generate the haystack again for you. We're gonna toss that out because we're gonna use the header as the haystack. Also, this is another very small bug that really is pretty immaterial, but you just don't want to have to handle, is the capture group start indices. They're like offset because of this match length. For some reason, they're not in the CodeGen. So for this, I just offset it here. Ideally, you won't even have to think about this, but if you were to start writing this in the next hour, you would have to do this offset as well to deal with it. But that'll just normalize it to the kind of the start of the match, like the regex match. And in this case, we've only got one capture group, so we technically could just get the first index or 0th index and just change that, but it'll handle however many you have. Cool. And then, so this is like another example of like how I mentioned, maybe your circuit has like a bunch of different inputs. You can just put them together like this. So whatever email inputs plus whatever else you're operating on, put them together, toss them in Noir, execute them. And then this is how I mentioned with to and from emails. This is just the process of like turning a bounded vec into whatever you want to read, at least in JS. You might have to deal with it differently in Solidity or if you were using Aztec or something, Aztec contracts. Parsing it would be different, obviously, but if you just want to read it, there you go. All that other stuff was just, again, validation. So we do Current test. Yeah, this is gonna run slower because my computer's overheating. There you go. We got our email nullifier, pubkey hash, and we've also extracted out a timestamp now. And if we go look, that looks right to me. Yeah, so that's the process of like we've taken a ZK email circuit and integrated it with just arbitrary other functionality if you wanted to compose it. But specifically in this case, we also used regex for pattern matching. The one other caveat on regexing I will say is if your use case can support it, if you can just do string searching for one reason or another, it's going to be a lot cheaper. Regexing is a lot more secure. It's a lot more dynamic. You can prove exclusion with regex. You can only prove inclusion with Noir string search. So you need to be like cognizant of where you're using what, but that's definitely worth considering. Is regex is not always the optimal tool, but it is a very powerful one. Okay, I see 2 questions. Which library are you using for ZK email? I am using this library right here. So this is the code. This is github.com/zkemail/zkemail.nr. This is the actual library right here, right? So when I was showing the example, I was just importing via path. But for regex, it's the same code. What I actually do is I import it in nargo.toml. It's the most recent version. Go get it from zkemail.nr. And then it's exactly the same from here. It's just how you access it. Uh, is this the upbase? It's the up-to-date code base, but it is also dynamic. So this NoirHack demo branch adds JS on the fly. I don't know if that branch will get like orphaned or what. But because there are like a couple of small changes to some other bugs I found from just like the main branch that we're working off of. So I might just merge that back into the main branch pretty soon. It should get merged at least into the main like V2 branch. I don't know exactly what the timeline looks like for like overwriting all of ZK regex with that. That branch is the most up-to-date Noir code though. I guess I will drop though the main repository. How do I do that? No clue how to use Zoom. Or chat. Okay, there we go. No, it's not showing me chat. I'll post that in a second, actually. I'll let other people finish up. Are there any restrictions on decomposed regex parts? That might be a better question for Ayush.
Yeah, I think in terms of decomposed regex, there's kinds of in the old compiler, which is kind of what is live, I think right now, um, there was like some restrictions on basically not being able to use like, you know, non-deterministic things like lookarounds. In the new version of regex, we still have you can't use non-deterministic things like lookarounds, but various bugs around certain things not working, like character classes, are now fixed. So basically, yeah, with the new compiler, you can use anything that you expect um, to not have to like loop around the regex multiple times. So as long as it's processing the regex in order, it should compile totally fine on the new regex compiler.
Um, yeah, Zoom is not cooperating with me right now. Okay. Yeah, I think that's everything. Again, the regex will be like there aren't really docs on it. The integration of it, this is by far like the recording of this is going to be your best friend. Also the Telegram can support through that, which I can throw up the links in a sec. zkemail.nr, a lot more documented. Still though, if you're having issues, go through the Telegram. That's probably the easiest way to get help. You can open an issue as well, I suppose, on GitHub. So yeah, definitely if you're trying to track the progress of the regex though, I would 100% be hopping in the Telegram because there should be some updates there. So I guess I'll pull up. Oh, and there's also Noir JWT, which I'm not super prepared to speak about right now. But it's very similar to how ZK email works. Obviously, you're validating JSON web tokens, but a lot of them are signed with RS-256, which is RSA. So definitely check that out as well, because there's a bunch of other really interesting things that you can do that are very similar to ZK email, except using JSON web tokens. So leave that up for a sec. Yeah, I guess, are you sure if you guys have anything else you want to say?
Yeah. All good, I think. Yeah. Yeah, if you have any more questions, also you can reach out to the Telegram, which is the main place where we support everyone. And yeah, to follow along with the work, you can also follow Twitter and our website. Yeah, and we will support anyone that will hack during NoirHack with ZK email. So yeah, don't know if Ayush wants to add something else.
No, it's great. Yeah, excited for people to ask questions and use the tech.
Awesome. Thank you guys so much. Also, we have a Discord, like a whole set of channels in our Noir Discord for NoirHack. If we could have one of y'all in there, I'll also share the Telegram too. But yeah, if anyone's asking questions in there that are more Noir specific, but they're also working on ZK email, be sure to tag ZK email in some way. Just mention that you're using ZK email. And then hopefully we can have maybe you can cross post it also in the Telegram. But cool, thanks everyone. This will be recorded, and we'll share it to the Notion soon. And I'll also add all the resources that the ZK email team has shared here in the Notion too. But thank you guys for joining. This is great. And yeah, I'm sure we'll get more questions from the recording, and I'll send them to you, and I'll also share the Telegram with everyone. Cool. Bye everyone. Have a good one.
Thanks.
Happy Monday.
Thank you.